Yeah. Good evening, children. Good evening. Yeah. Good evening, students. Good evening, Pradit, Danya, and Florentina.
Good evening, ma'am.
Good evening. Hi, Danya. Florentina, hello. So you've written this answer in your book. This image was shared and you have copied the answer, right, in your book? Correct? We only have to discuss the procedure, correct? And Ritika, you didn't attend the last online session, right? Yeah. Network issue or you were not able to take up the class? Still watched.
Ma'am,
Yes.
ma'am,
Yeah.
your screen is not shared.
Oh, yeah. Thank you. Yes, yes. I have not shared my screen. It must be visible now.
Yes, ma'am.
Yeah. All right. So this one, if alpha and beta are the zeros of the polynomial f of x equal to ax squared plus bx plus c, then evaluate. Okay. We need to find the value of this expression. And what's that? Yeah. We need to find the value of this expression. Beta by a alpha plus b plus alpha by a beta plus b. All right. Now here this a and b will remain a and b. AB will remain A and B. We'll have to get rid of alpha and beta. AB will be AB only. Alpha and beta is what you should remove from the expression. And see the final answer, how it looks like. The final answer looks like minus 2 by A. So A can remain. A and B can remain. Okay. So this is A alpha plus B. And this is A beta plus B. So the final answer can have any number. The final answer can have any sign, positive, negative. It can contain a number, any number it can contain. And it can also contain ABC. ABC, because they are the coefficients, no? A, B, C, they are the coefficients. So, but it should not have alpha and beta. The final answer should not have alpha and beta. Okay. So, so from this, you know that alpha plus beta is equal to minus B by A, which is minus B by A only. And alpha beta is equal to C by A, which is C by A. Correct? Okay. Then, so you need to start off by taking the common denominator. So what's the common denominator? The product of the denominators. The product of the denominators is the common denominator. So which is A alpha plus B into A beta plus B. That's the common denominator. And you know that if this is the common denominator, we have this. So we need to multiply. Okay, so if you have x by x plus y plus y by x minus y, what's the common denominator? What is the common denominator? X plus y into x minus y is the common denominator. Correct? And here we have x plus y. So the numerator should be multiplied by x minus y. Correct? See, the common denominator is x plus y into x minus y. And here we have x plus y. So the numerator should be multiplied by x minus y. So x into x minus y plus y into, here the denominator is x minus y. So the numerator should be multiplied with x plus y. X plus y. Just like we take the LCM. So it is the LCM, not just like. It is LCM only, common denominator only. So you can see here, the product of the denominators is the common denominator. So we have this one. So multiply the numerator with this A beta plus B. All right. And then plus the other term, this one as a denominator. So multiply this numerator with, this one. So basically this is multiplied with A beta plus B. And this is multiplied with A alpha plus B. Common denominator and this. So that's what you see here. And now we'll have to multiply. Children, is this fine, children? LCM, common denominator. Anybody has a doubt there? I can. See, this is the common denominator. See, this one is here. This one is here. This is not there. So multiply the numerator with this, a beta plus b for the first term. The second term has this one. It has this. It doesn't have this, right? So multiply the numerator with this one. That is alpha into a alpha plus b. In some schools, teachers say cross multiply. So it's not cross multiplying, but it looks like that, cross multiplying. Okay. So then open the bracket, a beta square, b. So I have written a and b first. When I multiply, I have written a and b first. Okay, I don't write alpha and beta. I write a and b first. So you can see here, beta into a beta is a beta square. Beta into b beta. Alpha into a alpha square. And alpha into b is b alpha. I told you I'm writing a and b first. The coefficients a, b, c, I'm writing that first. Divided by, you have to open the bracket in the denominator also. Because we know only two values. We only know that alpha plus beta is minus b by a and alpha beta is c by a. So you have to write all these, expressions in terms of alpha plus beta and alpha beta. You have to, now you see so many things in the numerator and denominator. All this should be written in terms of alpha plus beta and alpha beta. Only then where you have alpha plus beta, you can write minus b by a. And where you have alpha beta, you can write c by a. So you have to open up the bracket. So multiply this into this. Correct? That will be what? A alpha into a beta will be a square alpha beta. A alpha into a beta is a square alpha beta. Then a alpha into b. So it will be a b alpha. A b alpha. Then this into this. A b beta. And then this into this. B squared. B squared. Like we multiply the first term, no? So like a alpha into the second bracket, a beta plus b, then plus b into a beta plus b. This is how we multiply, right? The first term multiplied by the second bracket, the second term multiplied by the second bracket. A alpha into this one plus b into this one. So we open the brackets and we get four terms. We get four terms. Okay, so now you can see here this has a beta square, this has a alpha square. Now why are we gathering these two? And then we're going to gather b alpha and b beta, because you can take out b common between these two and you will have in bracket alpha plus beta. And you know the value of alpha plus beta is minus b by a. And if you gather this and this, again a will be common, and in the bracket you will get alpha square plus beta square. We don't know the value of alpha square plus beta square, but we know that it can be written as alpha plus beta the whole square minus 2 alpha beta. Yeah. So we gather, A alpha square and A beta square. A alpha square, A beta square. And then we gather B alpha and B beta. See, B alpha and B beta. All right. In the denominator, we have A square alpha beta. A square alpha beta. What did I tell you? A square is fine. Alpha beta is C by A. So that's fine. A square, you can have A square need not be replaced with anything. A, B, C need not be replaced with anything because A, B, C are the coefficients. A is the coefficient of X square. A, B, C are the coefficients. Coefficients can remain. Okay, so we don't want to replace A square in the denominator. In the denominator, we have A square. That's fine. Alpha beta. What is alpha beta? C by A. Then, so this is fine. A square alpha beta. So A square into C by A. And then this B square is fine. B square is B square. You don't have to replace that. And what you have here, you can take out AB common and you will get alpha plus beta. So like this, we have written everything in terms of alpha plus beta and alpha beta. So now, so in the numerator, I told you, rearrange the terms A alpha square, A beta square, B alpha and B beta. In the denominator, A square is fine, alpha beta C by A. B square is B square only. Now between these two terms, AB is common in bracket alpha plus beta. So we are almost done. Here we need to take out A common. When you take out A common, what will you get in the bracket? Alpha square plus beta square. And I've written that as alpha plus beta the whole square minus 2 alpha beta. When you take out A common here, you will get alpha square plus beta square. Correct? When you take out A common, you will get alpha square plus beta square. But what is alpha square? Because we cannot write anything for alpha square plus beta square. So we write it as alpha plus beta the whole square minus 2 alpha beta. So I've written that directly, children. You can also do this. You can do this, or you can give that extra step. So when you take A common here, you will get alpha square plus beta square. Again, we don't know the value of alpha square plus beta square. So we write that as alpha plus beta the whole square minus 2 alpha beta. Then plus taking out common here. Now we are ready. See, now we have the values of everything here. We know all these ones. Substitute. Do the substitution in one step. Meaning you wait till we change everything to alpha plus beta and alpha beta. And then you substitute once for all. So now A as it is, you can see this alpha plus beta is minus B by A whole square because alpha plus beta whole square. Minus 2 alpha beta, minus 2 C by A. Then plus B alpha plus beta. So plus B, alpha plus beta is minus B by A. And then A square, A square. This is alpha beta, which is C by A. And then this is AB, AB. And this is alpha plus beta, which is minus B by A. And this is plus B square as it is. So now we have substituted. We have only A, B and C. You can have A, B and C coefficients. And then this is, I think this should be comfortable for you. So A as it is, you see here. And then minus B square is B square. Minus B into minus B is plus B square. A square minus multiply 2C by A. And then multiply plus into minus minus. Plus into minus minus B square by A. That's about the numerator. In the denominator, A and A square you can cancel. So you'll have A here. You all know I cannot show that cancelling part. When I type, I cannot show that cancelling part. So you have to cancel. When you do this, you have to cancel. This is A. And now A into C is AC. And then A and A cancels. Plus into minus is minus B square. Minus B square. And then this plus B square. So minus B square plus B square gets cancelled. Minus B square plus B square cancelled. So you have AC. And in the numerator, I've taken the common denominator here. This one. A square is a common denominator. Correct? In the bracket here. A square is the common denominator. So this B square as it is minus, there is A here. So you should multiply by A to get A square. So that into A here. So minus 2AC. Minus 2AC. LCM. Common denominator. A square and A square is LCM. So here it is like A square is already there. So the B square comes as it is. Minus this is A. So A into A is A square. So multiply that A here. So minus 2AC. And minus B square by A. And in the denominator, cancel. So we have only AC. And now again, you can simplify this. This becomes A. This becomes A. Then B square minus 2AC by we cancelled. No? So by A minus B. This is A. This we cancel, it's only A. So B square minus 2AC by A minus B square by A by AC. So again, this one, the common denominator is A. A is a common denominator. So B square minus 2AC minus B square. Common denominator, A. So B square minus 2AC minus B square. Now see, this is the numerator, children. See, this is the numerator, this is the denominator. This is the numerator, this is the denominator. Numerator, this is the denominator. This is the numerator, this is the denominator. So please be careful. This is the numerator divided by, this is the denominator divided by this one. This is the denominator. So see, I've divided by AC. I've written the numerator here divided by the denominator here. Be careful which is the denominator. You keep observing from here. This is the numerator, denominator. So this one is here, this one, numerator and denominator. This is the numerator, denominator. This is the denominator, denominator. So divided by AC, divided by AC. That is, this is the numerator divided by denominator. Okay, now B square minus B square cancels. So we have minus 2AC by A. Division becomes multiplication and reciprocal, 1 by AC. That's what we always do, no? Division becomes multiplication. See, if this one cancels, so we have minus 2AC by A. Division becomes multiplication. AC becomes AC by 1 it is. So it becomes 1 by AC, reciprocal. Now again simplify. AC and AC gets cancelled. So minus 2 by A, minus 2 by A. So the value of this expression, evaluate means find the value of. Evaluate meaning find the value of. Find the value of. So the value of this expression is minus 2 by A. Minus 2 by A. Again, I'm repeating, you don't have to replace A, B, and C. A, B, C will remain A, B, C. Only alpha and beta you'll have to replace. Okay, minus B by A and C by A. And to do that, in this case, we had alpha square plus beta square. You're sleepy? You're tired? Madhumita? What happened? Sorry. Okay. Yeah, we have alpha square plus beta square here. We write that as alpha plus beta the whole square minus 2 alpha beta. All right, children? Yeah. So how to practice this? You should see this and work. You must never try working on your own. You know, like in the first shot itself. You should never try to do that. You should keep your, book, this tuition notebook beside and your rough notebook. You should just have a look at the working and work. That way also you can learn. Never think that you should do it, like by yourself without seeing. You can see and work. That way you learn it correctly for the first time. So when you work it, for the first time with it without seeing and you go wrong, it puts your mood off. Then you don't want to work, like you become cranky and you're like, you're not getting it correctly. So you don't feel nice to proceed. So you judge yourself correctly. If you feel you can do it correctly without seeing, do it. Otherwise, you see and work it. That way also you can practice. You should do something, you should practice, you should work out in a way that keeps you motivated. You shouldn't get tired with it. Yeah. So you have written this in your notebook, right, children, all of you? Yes. So your Kritika, is it? Your Kritika. Huh? Ritika. Krishita. Oh. So you were the one, no, who came last Saturday, and I'm sorry about that. Yeah. I don't know what, I spoke to your mother, I think, after that. Yeah. Sorry? Oh, not now. You have the image with you? Okay, yeah, you completed. Why you had so much time? Yeah, I understand. No. I'm not judging you like that. I understand. I know schools are crazy these days. I know that. So, yeah, but make sure you complete it. So here also, children, the same thing. So now I have to compensate 2 classes, right? One last Thursday and another one, no? Or only one? Only one class I have to compensate, is it? Is it okay if that is an online class for all of you? Ritika has some internet issues. You're not able to. Okay. No, in the earlier, one of the earlier online classes also. Okay, it's comfortable, right? Okay, because online is easy to make, like the Sunday I can make it in the morning from 6 to 8:30, something like that. Last year you used to say that Sunday is the only day I sleep. Is the Sunday, in case I make a class at. Oh yeah. Yeah, it's easy to compensate with an online class because then I have the flexibility to do it in the morning also. If you wanted offline, then like I have to think when I'm free in the evening. So is it okay if I compensate this class as an online class? You don't know. Well, you have to ask your mom, no? Mostly the Sunday. This is what now it's Thursday, right? So we'll have a regular class on Saturday. Yeah, most Sundays only. Sunday, sometime on Sunday. That's it. Okay, I can tell you that on Saturday. What time is not comfortable on Sunday for you? Morning, you don't want. After what time in the morning? After 3:30, yeah? You sleep till 3 then? Then no, you have some other class or something? You're not in 7th standard, you're in 10th standard. Oh my God, now I understand why you don't have time to complete your work. You were not busy, you were busy sleeping. All right. After 3:30, do you attend any other class? Oh no, you cannot afford to be lazy in 10th standard. Yeah. So I'll tell you on Saturday when the class will be on Sunday. Okay, so the online class I can compensate on Sunday. Yeah. Okay, this is the next one. Online students, was the earlier one clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now again, we see here f of x is ax square plus bx plus c, which means again alpha plus beta is minus b by a and alpha beta is c by a. We need to find the value of this expression. Okay, so write down what we need to evaluate. This is what we need to evaluate. You can see the a here, LCM here, common denominator, alpha beta. Alpha beta is a common denominator. So a square alpha. Oh, sorry, that's not a square. That's alpha. Sorry. This is not a, it's alpha square. Sorry. So a, you can see the a outside here. Alpha beta. Alpha beta is a common denominator. Alpha beta is a common denominator. So it will be alpha square into alpha, alpha cubed. Beta square into beta, beta cubed. Plus b, again alpha beta is a common denominator, alpha square plus beta square, alpha square plus beta square. So we start with taking the common denominators for these two brackets. That is the first step. And now what do you understand here? A cube plus b cube should be written using the identity. So a cube plus b cube is a plus b the whole cube minus 3ab into a plus b. So the identities must be at your fingertips or tongue tip, whatever. If you have to say orally, it should be in your tongue tip. If you're writing, it should be at your fingertips. So make sure you remember the identities correctly. A mistake with a plus or minus sign, all your efforts will go in vain. Or plus or minus sign, or minus a plus sign, or cube of power math. Oh, somebody just close the door, slide the door properly. Thank you. All right. So a cube plus b cube is, or alpha cube plus beta cube is alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta by alpha beta. And then here plus b. This one should be, why are we writing using the identity? Because we need to write it in terms of alpha plus beta and alpha beta. That's the reason. Not that we know so many identities and we are trying to show off. No. We know because alpha cube plus beta cube has no value. Meaning we do not know the value. So this is written like alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta because alpha plus beta is minus b by a, alpha beta is c by a, this is minus b by a. For that reason. And here alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta because this is minus b by a and this is c by a. Now we have everything in terms of alpha plus beta and alpha beta. Now substitute. You know how to substitute. So after substituting, see here, See here, after substituting, next step here. So this A as it is, can you see this A here? A here. And then here, first simplify. Don't take the LCM straight away. First simplify the brackets. So what is minus B the whole cubed? Minus into minus into minus is minus B cubed. So minus B cubed. If it is minus B the whole square, minus into minus is plus. So it's only B square. It's only B square. But this is minus B the whole cube. Minus 3 times when you multiply, you will get minus. And B when you multiply 3 times, it is B cubed. And then denominator A cubed. A cubed. See here, A cubed. And here minus into minus is plus, and 3BC by A square. 3BC by A square. You can see here. Okay, you can see here. Minus into minus is plus 3BC by A square. Okay. And then what I've done is this is divided by C by A, right? So I've written it like this. This is more convenient. Divided by C by A. This is more convenient. So divided by C by A. This one is the denominator. This one divided by C by A. So this is the numerator divided by C by A, which is the denominator. All right. Then. If you want to, I've done that in the next step. Have I done it? Oh, instead of into, I've put plus by mistake. This is into. I've typed it as plus by mistake. This is into. In the next step, I've done it. I've done it in the next step. It's better you show the steps. So that in case you want to check, in a hurry also, you know what you've done. So then again, the next bracket plus B. And then here minus into minus is plus B square by A square. B square by A square. Then minus 2C by A. Minus 2C by A. See and multiply. Minus 2C by A. Okay. Then divided by C by A. So I've written that like this. Divided by C by A and close bracket. Now again LCM. This one LCM here. A cubed. Oh my God. From where did I write all this? A cubed. No, there's some mistake. Sorry. A cube is LCM, children. What did I do? No, this by mistake I've typed. In case I've sent the slide to you, you'll have to correct it. This one is by mistake, children. It's not there. A cubed and A squared. Every time the teacher makes a mistake, meaning mistake, children are like, you start smiling. While typing, some typing error. Okay, ignore that. A cubed and A square. A cubed is LCM. Okay, always the highest power is the LCM. A square, A cubed, which is the highest power, A cubed. That's the LCM. Okay, so A cubed only will come here. Only A cubed will be there. So this minus B cubed as it is. Okay, A cubed, so minus B cubed as it is. And here we have A square. So we should multiply the numerator with A. A square, no? So into A is A cubed. So multiply the numerator with A. So 3ABC. Then this division becomes multiplication, children. This multiplication. And this C by A becomes A by C. Then plus B. Oh my God. Okay, plus B. And here A square and A square is LCM. A square is LCM. So B square as it is minus this is into A. A into A is A square. So that into A here. So minus 2AC. Division becomes multiplication. C by A is A by C. All right. Okay, so many corrections here. This is not there. This division is not plus, it's multiplication. This is also not there. And now you can cancel, right? You can cancel. So now you have this A cubed here and A outside. So you can, this becomes A square. And then this A here also, and A square here. So A. You can simplify. This is not there. This is into. So you can cancel. See this A and this A cube. So A square. Then this A and this A square, it will be A. Now this A into C is AC. It's all multiplication. So you can cancel. See, it's all multiplication. See here, A into this one, into this one. It's all a product. So you can cancel. So you can cancel. So you can cancel. So it's like this A and this A cubed, it becomes A square. Then this A and this A square, this A here. So now A into C is AC. The numerator minus B cube plus 3ABC as it is. And here I told you this is not there. This is not there. A and A square, when you cancel, you get A here. So AC is the denominator. AC. AC. B does not get cancelled. So B into B square is B cube, and B into minus 2 is 2AC is minus 2ABC. Which one? 1 minute. 1 minute. Just 1 minute. I'll strike it. Then you tell me. Ask me. 1 minute. Yeah. Now tell me. You're talking about this term. Are you talking about this term? Both the terms. Okay. Oh, this C and this C, is it? No, this one is an expression connected by a plus sign. You cannot disturb that. Whenever, see, if it was B cube minus B cube into 3ABC, you can cancel. But when the connected is a plus or a minus, it is one expression. See, for example, when you have A minus B by A plus B, you cannot cancel A and A, B and B. Because A minus B is an expression. A plus B, see, when the terms are connected by a plus or a minus sign, you can cancel them as a whole. You can cancel an A minus B with another A minus B. When the terms are connected by a plus or a minus sign, you can cancel the expression as a whole. Like A minus B with another A minus B. You cannot, so like here, as I told you, if you had A minus B by A plus B, so A minus B is one expression. There are two terms. They are connected by a minus sign. This is one expression. You cannot cancel this A and this A. They are not free. They are not free. They're meaning they're together. Like you cannot look at A separately. This A plus B also. The connecting sign is plus. You can cancel this A plus B as a whole with another A plus B here in the numerator. But A, B, B, we cannot cancel. Similarly here, this one. Similarly here, this is an expression minus B cubed plus 3ABC. You cannot cancel minus B cubed with something else. You cannot cancel this 3ABC with something else. Now you will say in 3ABC, it is 3 into A into B into C. In 3ABC, it is 3 into A into B into C. But however, it is one expression here because this term and this term, they're connected by a plus sign. So it's one expression. You can cancel that with another minus B plus 3ABC in the denominator. You cannot, yeah, you cannot cancel. So here you cannot cancel the C and C because B square minus 2AC is one expression. So you cannot cancel like that. So here, all that you can do is this A and this A square. So it becomes A. A into C is AC. And in the numerator, B into B square is B cubed. B into minus 2AC is minus 2ABC. Now, again, common denominator is AC, AC, AC. So AC, write all the terms. Now minus, you know what to do, right? Write all the terms. Now minus B cube plus B cube. Now 3ABC minus 2ABC is ABC. ABC by AC. Now you can cancel. See, if it was A plus B plus C by AC, you cannot cancel. You cannot cancel A, C, C. You cannot cancel. If it was A plus B plus C by AC, this only is the answer. Because this you cannot disturb. But what is it? It is ABC by AC. A into B into C by A into C. So it's product. Now they are free. You can cancel A and A, C and C. So the result is B. So the value of this expression is only B. This one is B. All right, children? Is that fine? Yeah. Now, tell me in your school, see, in my material, I have up to biquadratic polynomial. Up to because we had the 2 years before COVID, we had so much in polynomials. So my material is quadratic polynomials, cubic polynomials, and biquadratic polynomials, and so many other divisions and all that. Now, till what have they taught in your school? Only quadratic polynomials, right? Who's completed polynomials in school? Okay. Have you learned about cubic polynomials and by power 4, power 3? No, because last year it was not there. So the same thing continues this year. So I'm stopping. That's it. Then if it is only quadratic polynomials, that's all we have. There's lots more in polynomials, but then all that is deleted. Textbook, it's not there. Textbook, there's one of every kind, but it's there. There is one example about cubic polynomial in NCERT, and there is some one or two sums with biquadratic polynomials. There is a few sums, but that I don't think they've done. Have you done long division in polynomials in school? Long division now in 10th standard? That's what. That's what. So I'm stopping here. Maybe next class you all get your classwork. Let me have a look. Okay. It's not there because it was not there last year. So I'm sure I'll just double check. Just get your classworks in case you finish polynomials in school. I'll see to what extent they've done. If there is a little more, I'll do it. I have the material, so we'll do it in the next class. So now. Yeah, that's what even I did for real numbers. No, I thought this year what reason they have to delete, and I was teaching, and then luckily you people stopped me one day. Yeah, so I'll not do that mistake again. You don't have. Oh, yeah. Yes. Will do. All right, so now we'll just revise the whole chapter. Yeah. Yeah, children. Now it's my time, meaning now I'm free. I have nothing to explain. Yeah, start working. Take down the questions, start working. We'll see the answers. This is revision, chapter revision. Simple to difficult sums. We'll start with simple ones. Yes, online students, take down the questions, start working. Florentina, Prajit and Danya, please start working. Take down the question. Yeah, what's the answer for the first one? What's the value of alpha plus beta? So ax square minus bx plus c. Okay, we need to find the value of alpha plus beta. What is alpha plus beta? What are the values of a, b, c here? What is a here? A. What is a here? A is A. And
A.
what is B? Minus B. And what is C? C. Okay, now we need to find alpha plus beta. What's alpha plus beta? Minus B by A. So that is minus, what is B? This one is B. Minus B B is minus B by A. By A. That is A. So which is B by A? Which is B by A? Since we have small letter ABC already in the expression, take capital ABCs. Done, children?
Completed, ma'am.
Okay. Yeah. I haven't done graph for you. I'll tell you. I'll do it in this class.
Answer is 1.
Sorry. Yeah, zeros, roots are all the same. Roots, zeros, they're the same. Yeah. Sorry. No, we'll just answer this orally, children. You don't have to take this question. We'll just answer this orally. Yeah. So how do you make out the number of zeros? Yeah, it's the number of points. It's the number of points at which the graph intersects the x-axis. Now this graph intersects the x-axis at only one point. Okay. One. Now this graph intersects the y-axis here and the x-axis here. This graph intersects the y-axis here, x-axis here. Leave where it intersects the y-axis. That's not relevant to us. Okay, forget, don't, don't consider this one where the graph intersects the y-axis. Where does the graph intersect the x-axis? Here, at only one point. So the number of zeros this polynomial has, or the number of zeros represented here is 1. Only 1 0. The graph of this polynomial has only 1 0. Number of zeros is the number of points at which the graph cuts the x-axis only, not the y-axis. Y-axis it cuts here. Ignore this one. X-axis only here it intersects the x-axis. So number of zeros is 1. Not this point 1, not this one. At only 1 point. Now supposing we have a graph like this. Supposing we have a graph like this. We have a graph like this. Okay, so this graph intersects the x-axis here. 1, 2, 3, 4. So this graph, the polynomial represented here in this graph has 4 zeros. Now it intersects the y-axis here. Ignore that. Ignore where it intersects the y-axis. Count the number of places or count the number of points it intersects the x-axis only. So 1, 2, 3, 4. So number of zeros is equal to 4. So here it is 1. All right. Yeah. Yes, take down the question and work the answer, children. Take down this question and work the answer. Yeah, done. No, it doesn't take this long, children. Online students, answer.
Ma'am, we have to factorize this, right?
1 second, just a second, Prajit. Yes. 9/4. Can you read out what you've written, Tanishka? Oh, no, your steps. Oh, okay. Prajit, yes. The answer to your question is yes, Prajit. I heard your question. It's yes. Yeah. Possible. We just have to factorize the given polynomial. You just have to factorize it.
Yes, ma'am.
Yeah. So 4x squared minus 12x plus 9 is equal to, you can use the identity also to factorize a square minus 2ab plus b square, or you can split the middle term. I'll do it both the ways. 2x the whole square minus 2 into 2x into 3 plus 3 the whole square. So it is 2x minus 3 the whole square, or 2x minus 3 into 2x minus 3 using the identity. Okay, so 2x minus 3 is equal to 0. X is equal to 3/2. So the two zeros. So this polynomial has two equal zeros. This polynomial has two equal zeros. So alpha is 3/2. Beta is also 3/2. We can. No, that is when you get x square is equal to 9/4. If you get x square is equal to 9/4, supposing you get x square is equal to 9/4, then you will get x is equal to square root of 9/4. So which is plus 3/2 and minus 3/2. Uh, 4x squared minus 6x minus 6x plus 9, 2x. No, here you're wrong, no, because see, when you multiply plus 3 into 2x, you get plus 6x, no? Yes. And then here plus into minus is minus. You should take a minus here. It's a minus here. Okay? Yeah. Yeah, this is one way of doing. Okay, so you can factorize using the identity a square minus 2ab plus b square, or you can split the middle term. You can split the middle term. Okay, so the sum is, what is sum? Minus 12. And the product, 4 into 9, 36. 4 into 9, 36. So the required numbers are minus 6 and minus 6. Minus 6 and minus 6. Correct. So split the middle term. 4x square minus 6x plus 9. So 2x is common. 2x minus 3. This minus you should put as it is. Whatever the sign is here, you should take it as it is. Minus 3 common. 2x minus into minus is plus 3. Minus, we understand the signs now? Okay. So now 2x minus 3. No girls, no talking. So 2x minus 3 into 2x minus 3. So which means 2x minus 3 is equal to 0. X is equal to 3/2. So alpha is equal to 3/2. Beta is also equal to 3/2. Beta is also equal to 3/2. Is that fine, Krishita? Yeah, please complete, children, and let me know. Now you have written alpha plus beta and alpha beta, right? I'll tell you how you can do it like that also. Online students, you have to tell me if you're finished.
Completed, ma'am.
Okay. Are you there, Florentina?
Yes, ma'am.
All right. Finish this one.
Yes, ma'am.
All right. So supposing, because we're used to writing alpha plus beta, see, by now, we're used to writing this, right? Whenever we see a quadratic polynomial, we're used to writing alpha plus beta is equal to minus b by a and alpha beta is c by a. So what is alpha plus beta here? Okay, let me write the values of a, b, c. Let me write the values of a, b, c. A is equal to 4, b minus 12, and c 9. So alpha plus beta is equal to minus b by a minus b. So it's 3. And alpha beta is equal to c by a, 9 by 4. Now you can solve this by the substitution method. Okay, you can solve by the substitution method. Now, what is from this one? See, you can also do it like this. Okay, so from alpha plus beta is equal to 3. From alpha plus beta is equal to 3. What is alpha? 3 minus beta. Or what is beta? 3 minus alpha. Anything you can write. Okay, so substitute that in this one. Alpha beta is equal to 9 by 4. So alpha is 3 minus beta. 3 minus beta is equal to 9 by 4. So okay, so 3 minus beta many. Now gather the number. So you'll get 3 minus 9 by 4 is equal to beta, correct? Oh, you, sorry. Sorry. Yeah, alpha is 3, yeah, beta here again. So you get 3 beta minus beta square is equal to, minus 9 by 4 is equal to 0. So like this, again, you'll get a quadratic equation. Again, you'll have to split the middle term. Supposing you do it like this, find the two values for beta, substitute, and you'll get it. So this is going to be lengthy, right? This is going to be lengthy. Yeah, that's what you started, right? Yeah, this is what you should do. You'll again get a quadratic equation and you should go ahead with it. This is going to be tedious, so we'll ignore this. So this is what you should do. If you started like that, that's what you should do. But remember, when you have to find the zeros of the polynomial, it's just factorizing and finding alpha and beta. Simply factorize and find alpha and beta. The zeros meaning factorize the given quadratic polynomial and find alpha and beta. Yeah, this is the next one.
Ma'am, is the value of K 9?
9, is it? Okay.
I'm getting K as 9 as well.
Very good. Let's see. Yeah. Yeah, correct. Even I'm getting the same thing. K is equal to 9. Very good. So the sum of the zeros is 3. What is given? The sum of the zeros is 3. That means alpha plus beta is 3. Please write down. If you have not got it, please write down, children. Sum of the zeros meaning alpha plus beta is 3. So that means minus b by a is 3. Substitute and so whenever we have a polynomial, we write the values of a, b, c. Then it's given that the sum of the zeros, that means alpha plus beta is 3 is given. It's given that alpha plus beta is 3. But we know that alpha plus beta is minus b by a. And that is 3. What is minus b? Minus b is minus k by a, that is 3, is equal to 3. So on cross multiplying, we get k is 9. Yeah. This is the next one. If we are not getting the answer, children, you need to write down what I've written here. And friends, when you sit together, if you feel that somebody is doing better than you, sit separately. Because then we always feel that she's getting it, I'm not getting it. So that also leads to some kind of a feeling. So sit separately. Because one friend always finishes and she's waiting, and that might make you feel bad. I don't know. So if that's the case, sit separately. Don't sit with your friend. Oh, sorry. This is the question. How much? Minus 8. Okay. So Madhumita says the other zeros minus 8. So let's see. Plus 8. Okay. Okay. F of x is given to be x square minus 7x minus 8. So we'll write out the values of a, b, c. A is 1, b is minus 7, c is minus 8. Now what do we know? We know that alpha plus beta is equal to minus b by a. Minus b by a. So, but one of the zeros is given minus 1. So you can take minus 1 plus beta. Because one of the zeros is given. You can take minus 1 for alpha or beta, anything. Okay, I don't know. We'll see. So if minus 1 is a 0, that means alpha is minus 1 or beta is minus 1. Anybody. So I'm taking alpha as minus 1. See, this is what I know. I can write the values of a, b, c. Then after that, I can write alpha plus beta is minus b by a. But what is alpha? Minus 1. Plus beta is equal to minus b. Minus b is this one by a. So minus 1 plus beta is equal to 7. So beta is equal to 7 plus 1. So beta is 8. So the other 0, calculate the other 0. So the other 0 is 8.
You can do this by
You can also split the middle term. Yeah. You can also split the middle term. Yes. You can also split the middle term and do it. You can also split the middle term You can also try to use alpha, the other condition. Alpha beta is equal to C by A. What is alpha? -1 into beta is equal to C by A, -8 by 1. So beta is equal to 8, like this also. Or you can use any one of the two conditions, or you can split the middle term. You can split the middle term. If you substitute -1, you will get 0. No, you'll substitute. If you, in place of x, you're saying, no, 1 minute, in place of x. In place of x, if you substitute -1, you'll get 0. F of x is 0, you'll get. F of -1 is 0, you'll get. You can't find any value. If supposing there was an unknown like k or something, then you can substitute and you'll get the value of that k. Supposing there was some unknown. Here there is no unknown. No, if you substitute -1 in x, everything becomes number. Then what we're finding? So supposing there was something like k or something, then you can find that value of k. We can also split the middle term, correct? Yeah. Online students, can we go to the next one?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Yeah, we'll just do this orally.
2, ma'am.
We'll just do this orally. Don't write the question. We'll do it orally. Yeah, read and answer the question. So find the number of zeros lying between -2 and 2. Between -2 and 2.
2.
2, ma'am.
Yeah.
2, ma'am.
This is -2. This is 2. How many zeros are that? 1,
2.
2 zeros. 2 zeros. Okay. But otherwise, how many zeros are there? 1, 2, 3, 4. Not this one is not counted. Y-axis is not counted. Only x-axis. So otherwise there are 4 zeros, but between -2 and 2 is only 2 zeros. Only 2 zeros. Yeah. Yeah, now this is for you.
Especially one of the zeros the quadratic polynomial or both the zeros are quadratic.
If one is okay, the question is given like no, 1 is a 0 of the quadratic polynomial, then find the value of k. Case 4. Okay. So here some girls have got k4. Online students. I don't know if this is the correct answer. Some of us here have got k is equal to 4. Minus 4. Okay. -4. All right. So if 1 is a 0 means it's like x is equal to 1. See, that's what happens now when you split the middle term. When you split the middle term, you will get 2 values for x. You will get 2 values for x when you split the middle term. Meaning when you split the middle term and then you factorize it, you may get 2 values for x. So you'll get like x is equal to 1 or x is equal to suppose -3. This is the 0. This is only the 0. 1 is a 0, -3 is a 0. For example, 1 is a 0, -3 is a 0. That means x is equal to 1. 1 is a 0 means x is equal to 1. The value of x is 1. See that, okay, 1 is a 0 means alpha is 1, right? That means before we get alpha, x is 1 we would have got, right? 1 is a 0. That means alpha is 1, or you can say beta is 1. But before we get alpha and beta, we would have got x is equal to 1 or x is equal to 3. This we would have got first. And then we'll say, therefore, alpha is 1, beta is minus 3. So if 1 is a 0, that means it's a value of x. If 1 is a 0, so that means alpha is 1 or beta is 1. But to get the values of alpha and beta, we would have got the values of x. So if 1 is a 0, that means that the value of x is 1. So you can present your answer like this. Let, if the polynomial is not named, you can name the polynomial. So you can say let f of x be equal to x squared plus kx minus 5. And it's given that x is 1 is a 0. 1 is a 0. That means that is x is equal to 1. X is equal to 1. So now find f of 1. Find f of 1. What is f of 1? What will be f of 1? No, but what will be the value of f of 1? When you when you put the value of the 0 in place of x, what will be the value of the polynomial? It'll be 0. The value of the polynomial will be 0. See, 1 is a 0. So in place of x, if you use 1, the value of the polynomial will be 0. F of 1 will be 0. 1 is a 0. 1 is a 0 means in the polynomial, in place of x, if you put 1, the value of the polynomial is 0. That means f of 1 is 0. No, 1 minute. This is 9th standard. Let me see. I'll tell you 1 minute. Okay, I'll do it here. I'll take this one here. X square minus 7x or something else we factorize. No, we'll take that one. Okay, let me just take say x square minus 5x plus 6. Okay, what are the what will be the two values for x here? X will be, okay, x square minus 3x minus 2x plus 6. So x into x minus 3 minus 2 into x minus 3. So you get x minus 3 into x minus 2. So x is equal to 3 or x is equal to 2. Now that means 3 is a 0 and 2 is a 0. Okay. Now if you call this polynomial, say f of x, if you call it f of x is equal to x square minus 5x plus 6. Now x 3 is a 0 means x is equal to 3, right? So in the polynomial, in place of x, if you take 3, the value of f of 3 will be 0. See, you try that. See, what is 3 square minus 5 into 3 plus 6? 3 square is 9 minus 15 plus 6. 15 minus 15, 0. In the polynomial, if you, in place of x, if you substitute the 0, the value of the polynomial will be 0. See, 1 minute. I think I'm not clear. I'm saying like in f of x, what is f of x? X square minus 5x plus 6. Now, if you find f of 2, suppose you find f of 2, find what you get 2 square minus 5 into 2 plus 6. So you get 4 minus 10 plus 6. That is 0. But you find something else other than 3, 2. Find f of 1. Find f of 1. It will be 1 square minus 5 into 1 plus 6. So 1 square is 1 minus 5 plus 6. So it is 7 minus 5, 2. You will not get 0. Only for 3 and 2, you will get 0. For other values of x, it will not be, the value of the polynomial will not be 0. Only when x takes 3 or 2, the value of the polynomial will be 0. For there are so many other real numbers. For all other real numbers, for x, if you give any other real number other than 3, 2, it will not be 0. The value will not be 0. So that's what I'm saying here. Because 1 is a 0, f of 1 will be 0. The value of the polynomial is 0. And how do you find f of 1? The value of this one is 0. The value of this one is 0. This is the presentation. K is equal to 4. Now, some of you would have just got an expression, I'm sure. You would have just gotten. Have I gone wrong in calculating? Some of you would have just got an expression. Has anyone just got an expression? You would have just got 1 plus k minus 5 like this. Yes, yes. Suddenly you'll put it is equal to 0, is it? Okay, that's what. See, you cannot get an expression like this and then suddenly equal to 0. You should start from the beginning. You must write it from the beginning. That's what I'm writing here. I'm writing the condition first. This is the condition. Look at the board, girls. This is the condition. You should write that first. See, first name the polynomial. X squared plus kx minus 5. Let it be f of x. First name the polynomial. That's the first step. Then 1 is a 0. That is x is equal to 1. 1 is a 0 means x is 1. X is 1. Now, if x is 1, x is a 0. Meaning, sorry. 1 is a 0. That means f of 1 is 0. F of y, f of 1, because I've called it f of x. So f of 1 will be 0. And how will you find f of 1? 1 square plus k into 1 minus 5 is equal to 0. Is equal to 0. 9th standard. So I wrote the condition first. I first wrote the condition f of 1 is 0. Then I'm working with that condition. F of 1 means 1 square plus k into 1 minus 5 is equal to 0. So on solving this, we get the value of k. Yes, you got minus 4, right? Yeah, simple again. Do it fast. Present it correctly. You should find the other 0 here. Oh, then you don't have to do this. Not k. Find the other 0. Use a suitable condition. Don't use the sum of the zeros here because that will be, you'll get k in that. If you use sum of the zeros, you'll get k in that. So use product of the zeros. You can find. Then how will you proceed? You have beta as unknown, k is also unknown. You can't find anybody there. You write, that's good. After writing, you'll realize that you want to find beta, but there's also k which is unknown. So you cannot work with that condition. So take the other condition. What's the other condition? Alpha, beta, c by a. Now in this, if you work, only beta is unknown. So this will be useful. It's okay if you write that in the exam, but you'll realize, no, then you strike it out and then do it like this. Sometimes that condition will work. It depends on what is given. Sometimes we have to use alpha plus beta is equal to minus b by a. Sometimes alpha, beta, c by a. So when you start working, you'll realize. 2.5. Yeah. Children, any question? Online students?
No doubts, ma'am.
Okay.
No, ma'am.
You can use any one of the two conditions, whichever works. You can use alpha plus beta as minus b by a, if that will be helpful. You can leave it like this. Minus 5 by 2 is fine. Yeah, this is your next question. X to the power? Yeah, repeat. Okay. Okay. Repeat x square. X square minus x minus 12. Huh? Correct? Okay. So we'll recall how do we construct a quadratic polynomial. Here we have to construct the quadratic polynomial. So what are the two ways in which you can construct the quadratic polynomial? So it is x squared minus alpha plus beta of x plus alpha beta. Or you can also construct using x minus alpha into x minus beta if the zeros are given. If the zeros are given, see, supposing the zeros are given to be 5 and 2. The zeros of 5 and 2, that is alpha is 5, beta is 2. Supposing the zeros are given, then x minus 5, x minus alpha, and into x minus beta, x minus 2. If 5 is a 0, x minus 5 is a factor. If 2 is a 0, x minus 2 is a factor. If minus 5 is a 0, x plus 5 is a factor. If minus 2 is a 0, x plus 2 is a factor. The product of the factors will give you the quadratic polynomial. When you just multiply these two, you'll get the quadratic polynomial. That's one way. You can get the quadratic polynomial using any one of these two. X minus alpha into x minus beta. If you know alpha and beta. But here you don't know alpha and beta. You know the sum and the product. Alpha plus beta is 1 and alpha beta is minus 12. So we'll use this one. How? X squared minus alpha plus beta of x plus alpha beta. We'll use this format to construct the polynomial. Yeah, somebody's saying something. Different method, huh? Okay, I'll see. Correct? Yes. Minus b by a, then minus b. So explain what we have done. Alpha plus beta is 1 and alpha beta is minus 12. Then alpha plus beta is minus b by a and then minus. No, how did you write minus 1 here? Okay, this minus and b, how do you know? How do you know it's 1? No, I don't know, I'm asking you. This b value, how you got 1 and a value, how you got 1? Huh? Huh? Okay, very simple. For this sum like this, if the sum and product are different for that, what will you do? Huh? Formula. But anyways, you will not do this method, right? No, you explain what you've done. Why 1 by 1 I want to do. I know how it is, but you don't do like that. Do like this. Sorry? Which method? X minus? You can't do that because 1 and minus 12 are not the zeros. They are the sum and product of the zeros. We can't do that. Here we cannot use x minus alpha into x minus beta because 1 and minus 12 are not alpha and beta.
Yes, ma'am.
1 is alpha plus beta and minus 12 is alpha beta. No, I only got confused for a minute. What is 1 alpha plus beta and what is minus 12 alpha beta? So you cannot use this here. We cannot do this. We cannot do this. X minus alpha into x minus beta. This one you can do when you know alpha and beta. In any case, you can do this method. This standard form you can always do. If you know alpha and beta, you substitute here. This one you can all universal. Any information, whether you are given alpha and beta or if you're given alpha plus beta and alpha beta, in both you can use this method. This method you can always use. 1 minute, I'll just redo this. So we're given alpha plus beta is 1 and alpha beta is minus 12. So the standard form is x squared minus alpha plus beta of x plus alpha beta. This is standard form. So x squared minus alpha plus beta, that entire value is 1 plus alpha beta. The whole thing is minus 12. So x squared minus x minus 12. Now supposing we are given the supposing not here, okay? Supposing alpha is 1 and beta is minus 12. That is if the zeros are 1 and 12. Then also you can use this method x squared minus alpha plus beta of x plus alpha beta. Here what you should do, x squared minus alpha is 1, beta is minus 12 of x plus alpha is 1 and beta is minus 12. So the polynomial will be x squared. This is what? Minus 11. So plus 11 it will be plus 11x minus 12. Whether you're whatever be the information, you can use this method. This is the standard form. X squared minus alpha plus beta of x plus alpha beta. So if you're given alpha plus beta and alpha beta, substitute. If you are given alpha and beta, that also you can substitute here, but be careful in doing that. Correct, children? Yeah. Online students, any questions?
No, ma'am.
Clear, ma'am.
All right. What is your name? Sri Ranjan, no? Why did you watch? Okay, I'll talk to you later. Yeah, this is your next question. I think we did all this. 1 minute, 1 minute. One class, we did all this. Just flip back and check. 1 minute, children. I think we've already done this. A set of 10, 12 questions. I think in an online session, I did this. No, I did. Didn't. See, the same thing, correct. Done on this. Yeah. Couldn't write this from any YouTube, you know. Channel, no? See, this 21 by 8. N by N. Yeah, we've done all this. Till here I've done. M by N up till here I've done. M by N. This till here I have done. Okay, 1 minute. We have done all this, children. 1 minute. This I can give us homework, all this. Negative of the other, all this is easy for you. Okay, fine. Yeah, we'll continue from here. Yeah, this is the next question, children. Please take down the question. This is your next question. Please take down and answer this. Yeah. Yeah, just work. You multiplied by 2. Okay. Okay. Including 9 by 2 everywhere. Three common I tell. How can you take 3 common? 3 alpha into 3 beta. 3 3s are 9. Yeah, am I right, children? Correct. You got to x square minus 9 by 2x plus 9 by 2. You can leave it like that also. Or it's not equal to or. One second. Online students, let me tell you the procedure. All of you listen. So we are given a quadratic polynomial. We are given a quadratic polynomial 2x squared minus 3x plus 1. So as always, write out the values of a, b, and c and find alpha plus beta and alpha beta. Minus b by a, c by a, have those values. Now, what is the question? The question is, construct a quadratic polynomial, a different quadratic polynomial, whose zeros are 3 alpha and 3 beta. What are the zeros of the given polynomial alpha and beta? So you must construct a quadratic polynomial whose zeros are 3 alpha and 3 beta. Now the given polynomial has zeros alpha and beta. You must construct a polynomial whose zeros are 3 alpha and 3 beta. So that means the standard form, no, x square minus alpha plus beta of x plus alpha beta. But that you can write only if, see, you can write x square minus alpha plus beta of x plus alpha beta if alpha and beta are the zeros. But here 3 alpha and 3 beta are the zeros, right? So you should not write this. That's why we write x square minus sx plus p. Otherwise, you know what you should write? You should write x square minus 3 alpha plus 3 beta of x plus 3 alpha beta. Don't write it like this. I'm just telling you. You must write this one. What is the standard form, children? Please listen. The standard form is x square minus alpha plus beta of x plus alpha beta if alpha and beta are the zeros. But what are the zeros here? 3 alpha and 3 beta. Then what will be the standard form? X square minus 3 alpha plus 3 beta of x plus 3 alpha into 3 beta. You should add the zeros and Find the product of the zeros. The zeros are 3 alpha and 3 beta. So you cannot write this one. This is not the standard form. Meaning this is the standard form if alpha and beta are the zeros. So if 3 alpha and 3 beta are the zeros, then the standard form is x square minus 3 alpha plus 3 beta of x plus 3 alpha into 3 beta. You should write the zeros here. So now we cannot do this for everything. So we take this one, x square minus sum of the zeros into x plus p. Sum of the zeros. This is sum of the zeros plus p. What is actually here alpha plus beta? That's what sum of the zeros. And here it is alpha beta. So product of the zeros. So this one, this required sum is only s. This required product is p. Yes or no, children? Okay. Yeah. So you find, as always, find alpha plus beta and alpha beta. Now, what is the required sum? Now, for this quadratic polynomial which you want to frame, what is the sum? 3 alpha plus 3 beta. So 3 is common, alpha plus beta. And what is alpha plus beta? 3 by 2. So 9 by 2 is the required sum. That is the 3 alpha plus 3 beta. That's sum. 3 alpha and 3 beta are the zeros. So what is 3 alpha plus 3 beta? That required sum, 9 by 2. What's the required product? What are the zeros? 3 alpha and 3 beta. So what's the product? 9 alpha beta. And what is alpha beta? 1 by 2. So 9 by 2 is the product. Now consider the polynomial. So x square minus sum of the zeros into x. So sx plus p, capital S and capital P. Substitute the values. Now this one you can multiply by any non-zero real number. So you can multiply this by 2. You can multiply this by 2. So then you will get 2x square minus 9x plus 9 by 2. Let me explain this alone. You can stop here, children. You can stop here, or you can multiply this one by 2 throughout. So 2 into x square, 2x square. This one into 2, 9 by 2x into 2. 2 and 2 will get cancelled, so minus 9x. 9 by 2 into 2, 2 and 2 will get cancelled, plus 9. Multiply everything by 2, this one by 2, this one by 2, this one by 2. So 2 will get cancelled, 2 will get cancelled. Correct? 1 minute, I think. You can also do it like this, I'm saying. Okay, so you can also multiply this x square by 2. X square, this one into 2, minus 9 by 2x into 2. Multiply every term by 2, plus 9 by 2 into 2. You can multiply every term by 2. And then you will get 2x square minus 2 will cancel 9x. 2 cancels plus 9. This polynomial will also have the same zeros, 3 alpha and 3 beta.
We are multiplying by 2 just because it's the denominator will be or
Yeah. Just because you can multiply by 4 also. You can multiply by 10, 20, any number. Here we are multiplying by 2 so that we can get rid of the denominator. Yeah. But you can multiply by any non-zero real number. But actually, see, these two polynomials will have the same zeros, 3 alpha and 3 beta. In general, supposing 1 second, you're solving some, supposing you have 2x minus 4y plus 5. Now here you cannot multiply by 2 throughout and write 4x minus 8y plus 10. This is wrong. You cannot simply multiply an expression by 2. You can multiply an equation on both the sides by 2. This one is, in this case, like even if you multiply by 2, this polynomial will also have the same zeros, 3 alpha and 3 beta. Only here you can do this. Not everywhere. Yes. You're actually finding alpha and beta, and then you put it there. That is, you found 3 alphas. What is this? No. In like this means what you should do, you found alpha and beta, right? I assume that this is right. So what is now if you do it like this, if this is alpha and this is beta, so then you have to show different. Don't do it like that.
But multiplication and addition are commutative, so it can be in any number.
No, if you take this one as alpha and this one as here, because 3 alpha and 3 beta it will work. But if it was 3 alpha and 2 beta, then if you take alpha as this one, then these values will be different. If you take alpha as this one, the values will be different. You understand?
Yes, ma'am.
Yeah, so don't find the zeros like this.
But in this case, like since both of them are 3, I'm still supposed to get the answer.
Okay, let me see. So you got 1 and 1 by 2, is it?
Yes,
So
ma'am.
3 alpha will be 3 and 3 beta will be 3 by 2. So you're saying x square minus 3 plus 3 by 2 x plus 3 into 3 by 2. No, this is alpha, this is beta. This is 1 0, this is the other 0. So 9 by 2 will be a beta. Online students, please ask me if you have any doubt.
No, ma'am.
Okay, Danya and Florentina.
No doubts, ma'am.
No doubts, ma'am. All right. Yeah, sure, sure. I'll take a picture here. You're getting it there? No, no, I'll send you. I have 2 numbers of yours. I don't know. I've sent it to one of the numbers. One of the 2 numbers. Okay. All right, children. So this is the next one. One minute. Let me take up some more. Let me just look at the others. Yeah, do this one, children. This is your next question. This is your next question, children. Did Rakshita attend school today? She's in your one of your sections. All of you belong to the same section. You 3. No. You both. You're in a different section. Okay. Rakshita is in some other section. Your section, huh? She was in school today? Okay. And all of you are in seeker section, huh? No, you? No. Okay, you are also not in that section. Sorry? Should come with us, yeah? That's why. You shouldn't teach. Oh, you go by the same autos, yeah? Oh, nice. Okay, so nobody's in seekers here. You 3 also, nobody's in seeker section. But there's a section like that, right?
Yes.
With seekers.
Yep. Yes. Yep.
But you would have tried it at least. Oh, you didn't try it at all? Meaning not 10th standard, 9th standard. No, 8th. Oh. You have not tried the term. You are in seeker section in school. Okay. Yes, children. But in your school, you have ETOs or something, no? Oh, they're different. They're not seekers. That is some Chennai based. Oh, okay. Take the table closer to you. You cannot find the zeros and work it. You should not find. See, some of us, what we do know, we find the zeros of this polynomial. So when you find the zeros like 2 and 3, then we put it in that 1 minus alpha, 1 plus alpha. You're not expected to do it like that. You have to do it like this. Did you do it like that? Because you've got the answer already. Give me a bit. Come. Oh, okay. Then this should be right. Yes. Yeah. Now you've got the sum of the zeros, and where's the product? You have to still find the product. Sum you've got. Find the product. Multiply the two things. And then you should put it in the standard form. X squared minus sx plus 2. You're correct. Meaning, I don't know if this answer is right, but the procedure is correct. Yeah. Continue. substitute in it. Am I working it correctly, children? My calculation, please check. As you're working, you check. As you're working, you just check my calculations. Tell me if I'm right, then I'll do the next one. So this is how we find the sum of the zeros. I've only found the sum. I still need to find the product and then construct the polynomial. Let me know if my calculation is right, children. What happened, Trishita? You finished till here? Try the product. Okay, let me ask you. Trishita, we'll do it together. Online students, this is over, meaning this part.
Yes, ma'am.
Okay, we are not doing this sum actually now. I'm just taking this slide. We are not doing this question. The earlier one only, I'm just working it here. Sorry? Yeah, I'll just, yeah. Sorry? Louder, louder. After this step, huh? You want to know how I got this one? Yeah, okay. Or you understand, did you understand how we got this one? This one, huh? Let me finish. I'm going to explain it anyways. Let me finish it. Yes, Krishita, how do you multiply? Multiply the numerators, multiply the denominators. Okay, so how will it be? 1 minus alpha into louder 1 minus beta divided by 1 plus alpha into 1 plus beta. How do you multiply? No, nothing is in the book. Look at the board and tell me. Multiply 1 with the second bracket. What's the second bracket? 1 minus beta. Then minus alpha into 1 minus beta divided by, how do you multiply this? 1 into how 1 plus alpha? 1 plus beta. Then sine plus alpha into 1 plus beta. Next step, multiply. 1, multiply and tell me loud. No, on the board. Tell me, I'll write. Don't write. Multiply in your mind and tell me. Yeah, fast. What is 1 into 1? 1. Then what is 1 into minus beta? Sine. How plus 1 into minus beta is minus beta. Then what is minus alpha into 1? No, is the board not clear? Minus alpha. I think you're nervous. I should be nervous. I'm talking and so many of you are watching me. I should only be nervous. And then sine plus alpha beta. See, you know it. Divided by yeah. Now see, what will you do next? Minus beta minus alpha. Take out minus common there. First you write it like this, right? Minus alpha minus beta plus alpha beta. Just rearrange. Now tell me in the same way in the denominator, what will you write first? Very good, yeah. Now in the numerator, take out minus common. Then what will you get in the bracket? Plus alpha beta. You take minus common, it will be minus alpha. Yeah. Now substitute the values. 1 minus, what is alpha plus beta? Minus 2 by 3. Minus 2 by 3. Plus what is alpha beta? 1 by 3. Divided by 1 plus minus 2 by 3. You cannot cancel alpha plus beta and alpha plus beta because there's plus minus sign and all that. Plus 1 by 3. Now you need to simplify this. Okay? Yeah. Take down all of you. But if you have already started working, see if I'm right. One second. I have to take the next slide. There's no place here. Children, I'll just continue here. I'm sure you will not get confused. I'll just continue here, children. After this, I'll continue here. Is equal to 1 plus 2 by 3 plus 1 by 3 divided by 1 minus 2 by 3 plus 1 by 3. Now LCM. 3 plus 2 plus 1 by 3 divided by 3 minus 2 plus 1 by 2. 6 by 3. 6 by 3 divided by 2 by 3.
Can you cross multiply?
Where cross? This is an expression. How can you cross multiply?
Okay.
6 by 5 is 2. 6 by 3 is 2 divided by 2 by 3. So it is 2 into 3 by 2 is equal to 3. I squeezed it. I'm sure you will not get confused. You will understand. So the required polynomial is 2 and 3 we are getting. So 2 and 3, x squared minus 2x plus 3. Did you get that? Very good. Did you get the sum is 2 and product is 3? Very good, very good. Delete it. You finished work? Meaning, you finished this one? Hello? Yeah, send up. No, 5 minutes question. Yeah, okay. Yeah. Give me a book. Pass it on. Sit down. Very good. Yeah. Would you both do it together or you were doing it independently? But you're very confident in your working. So you're not, like writing the required stuffs. Like you're not writing required sum, required product, and the required polynomial and all that, because you seem to be very confident. I don't want to say overconfident. Yeah. So great job, but you need to present it properly. All right. You have not written required sum, required product, and all that, but very confident working. Very nice. Yeah, I don't know which slide to take. Online students can take a screenshot if you want, and for the others, I've just sent the photo on the group. Because I don't know if you've written all this, so for the others, I'm sending the photo on the group. So the required polynomial will be x squared minus sx plus p, x squared minus 2x plus 3. Correct? Very good. online students, I've sent the complete working in the group, on WhatsApp. So we are given a quadratic polynomial. We need to find alpha and beta, the zeros of the given quadratic polynomial. So find alpha plus beta and alpha beta. Then we need to construct another polynomial whose zeros are given here. These are the zeros. So you must find the sum of these zeros and the product of these zeros. So that's what we have done here. We found the sum of the, meaning the required sum and the required product, 2 and 3. And then the standard form, x squared minus sx plus p. So how many of you got the calculations right here? Sashant, Dileepan, got it right? Yeah, you got the first part right, second one also? Very good, very good. What about Krishmi? Sorry? Okay. Madhumita? Me, okay. Okay, but you understand what it is? Tell me what you didn't understand. Tell me. Okay, no, but what was the doubt earlier? Oh, okay. If alpha and beta are the zeros of this one, okay. If the question is evaluate, 1 minus alpha by 1 plus, if the question is evaluate 1 minus alpha by, oh, that was your doubt also, I think. You found the sum and left it. Okay. So if the question is evaluate 1 minus alpha by 1 plus alpha, some plus or minus 1 minus beta by like this. Evaluate means you should find only that value. Evaluate. But what is given? Find the polynomial whose zeros are this and this. That question will be like this. Oh, that was a different file, no? Sorry, 1 minute. Yeah, see here. If alpha and beta are the zeros of ax square plus bx plus c, evaluate. Find the value of this expression. Find the value of this expression. Then what you say is right. What you did. Just find the value of this one and leave it. But here the question is different. Oh, I guess that question is gone. Yeah. But here the question is find the polynomial whose zeros are 1 minus alpha by 1 plus alpha and 1 minus beta by 1 plus beta. Zeros are these. Find the polynomial. So you must find the sum of the zeros, the product of the zeros, and then construct the polynomial. That is evaluate. So much is not there for you all.
They asked the icon that is called this
I did all last year. I did for them. I did polynomials like I think I normally start with these. And the year before that, it was deleted. So last year also, I thought, why should it be deleted? Because schools have started off. Same thing I did last year. And then it was not there. But real numbers, certain chapters, we did everything actually. Because that will be useful for your higher standards. So we did everything. Like an arithmetic progression, certain chapters, I did most of it. I told them, whether you study or no, it's left to you. I'm just seeing if there's any other X squared question. We'll do this one and wind up the session for today. Okay, let me check. We have done this, but online students, this is your next question. 1 second, 1 second, 1 second. Yeah, do the which one? Do this one, children. Do this and this. Let me see who can give me the answer. Do only the third and fourth one. Raju. If you get the answer for the third one, please share it with me. Online students. Give me a book. Just pass it from there. Sit down and pass it. Pass this. Oh, so alpha minus beta the whole square is alpha square plus beta square plus 2 alpha beta. Minus 2 alpha beta will come. Okay. No, this is alpha minus beta the whole square. And you have written, it's like A minus B. Yeah, pass. Anybody else there? No, don't give out the answer. Just wait, please wait. Ask you 1 second. Yes, Sashan. No, you? Give me your book. Very good. Look at this boy. Huh? Sit down. I'll give you a book. Yeah, girls there? No. Oh my God. Yes, somebody online wanted to say, Raju, அந்த முதல் ரெண்டு switch போடுங்களே அங்க வந்திருக்காங்க. Yes.
Ma'am, I got -1.
-1, na?
I got -1 as well.
Okay, Danya, tell me, how did you get it?
Ma'am, I use the formula a minus b the whole square. And
Yeah.
with that, that is a square minus, I use the terms alpha and beta, ma'am. That is alpha square minus 2 alpha beta plus beta square. So I
Okay.
combined alpha plus beta the whole square minus 2 alpha beta.
Minus 2 alpha beta.
And then
And
I have written out the values for A, B, and C, ma'am. Alpha plus beta is minus B by A. I got 2, ma'am. 4 by 2, that is 2.
What is that finally you got? Finally you got alpha plus beta the whole square minus
2 alpha beta.
that's all.
Yes, ma'am.
That's wrong. That's wrong. That's wrong. Prajit?
Ma'am. I substituted
Yes.
formula, but I wrote alpha square and plus beta square as alpha plus beta the whole square, and I substituted the value and got -1.
No, here's one student who has done it the way. How?
And then alpha square plus beta square minus 2 alpha beta. So alpha plus beta the whole square minus 2 alpha beta.
Minus 2 alpha beta. 2 times. You forgot that other time. There's already one minus 2 alpha beta, right? You forgot that. Yeah. Very good. Yes, you also. Yeah.
Found that, ma'am. Actually, it is alpha plus beta the whole square minus 2 alpha beta plus alpha beta.
Alpha plus beta the whole square minus 2 alpha beta minus 2 alpha beta. Okay, so there is one student here in the class who's used the formula correctly. Yes, Dileepan, tell us what's the identity? Don't see the book. Tell me. Alpha plus beta the whole square.
Alpha plus beta means alpha plus beta the whole square means the whole and
That means you refer the identity behind. No. Then you should be able to say. Tell me. Okay, now look and say.
A is B and A.
No. So you have got that right. Now tell me the identity you've written there.
Alpha plus B. Alpha minus
Whole square.
equals square.
You didn't say that. Yeah. You forgot. Now repeat it clearly.
Alpha plus beta. Alpha minus beta equals alpha.
Very good. Okay, fine. Very good. So Dileepan has used the identity correctly. You can use this straight away, children. Listen, all of you listen. So see here, we know that alpha quite teacher. Okay, one second. Please listen to me. Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. Correct? Now what is alpha plus beta? Minus b by a. So it will be 4 by 2, which is 2. Correct? 2 square minus alpha minus beta the whole square is equal to 4 alpha beta. What is alpha beta? 5 by 2. Correct? Into 5 by 2. That's all. So to 4, this will be minus 10, right? Is equal to are we getting it negative? It cannot be negative. 2x square minus 4x plus 5. What's alpha plus beta from this? Minus b by a, right? So it will be 2. And what's alpha beta? C by a, 5 by 2. So alpha plus beta the whole square, that is 4. Minus alpha minus beta the whole square is equal to 4 alpha beta. 4 into 5 by 2. Oh, okay. All right. So 4, this one becomes, no, there's some problem with the question. It cannot be negative. So this is 5 was at 10, right? On this side, it will become minus 10 is equal to alpha minus beta the whole square, correct? So this is minus 6 is equal to alpha minus beta the whole square. This one cannot be negative. Probably while typing, I've made a mistake with the sign there, but this is the procedure. We understand that? You need to use this identity. Or what is in this identity, children? We have alpha plus beta, we have alpha minus beta and alpha beta. And you know the value of alpha plus beta. You know the value of alpha beta. So you can find alpha minus beta. We're getting a negative value, I'm saying. So there should be some problem with the question. Well, typing probably went wrong. All right. Otherwise, for others who have done this, see here, some of you have done this. Alpha minus beta, the whole square is equal to alpha square plus beta square minus 2 alpha beta. Minus 2 alpha beta. Then what is this alpha square plus beta square? Alpha plus beta, the whole square, minus 2 alpha beta. And minus 2 alpha beta, which is already there. So that is alpha plus beta, the whole square, minus 4 alpha beta. This is also correct. It's the same identity you're getting here. Same identity you're getting here. Minus 2 alpha beta, minus 2 alpha beta is minus 4 alpha beta. 1 minute, 1 minute. See, what are you saying? See, you tell me. Alpha square plus beta square minus 2 alpha beta. You understand this? Yeah, now tell me what is alpha square plus beta square? Alpha plus beta the whole square? Minus 2 alpha beta. Alpha plus beta the whole square minus 2 alpha beta minus 2 alpha beta. So this is alpha plus beta the whole square minus 4 alpha beta. Don't you think it's identity only? See here. Alpha minus beta the whole square, alpha plus beta the whole square, 4 alpha beta. So you must use an identity. So remember, to find alpha minus beta the whole square or alpha minus beta, you should use this identity. Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. You can use this identity to find alpha minus beta or alpha minus beta the whole square. All right. All right, children, it's time. All right, children, online students, that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Yeah, thank you, children.
Thank you, ma'am.
Thank you. See you.